Dampers. I'm Scott Arnold, Senior Manager of Publications and Standards for Air Movement and Control Association International. On behalf of our more than 400 members worldwide, I want to thank you for joining us. We realize there's a lot to see and do at the AHR Expo. We respect and value your time and hope you find this educational session worth your while. The information contained in this session is provided by AMCA as an educational service. In making this educational activity available, AMCA is not endorsing, sponsoring, or recommending a particular company, product, or application. Lastly, this session is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the material without written permission from AMCA International is prohibited. And with that, let's meet our presenter. With a unique background in the manufacture, marketing, application, and sale of a variety of HVAC products, Michael Balzomi is Product Manager, Commercial Dampers for Greenheck. He has been involved in the development of building standards, authored numerous white papers and trade publication articles, and participated on a number of technical committees. He is a member of ASHRAE and the National Fire Protection Association, and chair of the AMCA International Fire and Smoke Damper Subcommittee, and the Technical Committee for AMCA Publication 503, which is the association's application manual for fire smoke, combination fire smoke, and ceiling radiation dampers. Michael?
You're all here for the same purpose here. You realize the importance of life safety dampers, right? It's in the name. They save lives, right? We're going to go over the different types of dampers. We're going to talk about applications, code requirements, installations. I want you guys to walk away with at least one good fact about dampers. I got a couple of people in the room here, more than one. There's a bunch of different people at this conference. So quick show of hands. Who are my installing contractors? Code officials. Design engineers. All right. I'm going to talk. Anybody an architect? All right. I'm going to invite you back at 3 o'clock to talk about ceiling radiation dampers. But let's get into it. So why do we need dampers, right? We know the code requires them. They operate on a very simple principle, containment and smoke control, right? Containment compartmentalizes buildings. We create areas of refuse. We create fire-rated barriers. We protect areas. We protect rooms from, the things that are inside of them. Control the movement of smoke, right? Very large buildings, high concentrations of occupants in the buildings, places where it's hard to egress or evacuate and escape of a fire. There's certain code requirements, so we need to control the movement of smoke as well. And in doing that, we save lives and we save property. When we talk about dampers, we always have to start with UL Underwriters Laboratory. They are the preeminent certification and testing laboratory in North America. So we always reference their test standards. They're referenced by the International Building Code. So our life safety dampers go through what we call the 555 series of tests. UL 555 for fire dampers, 555S for smoke dampers, 555C for ceiling radiation dampers. Most importantly about UL, they have what's called a factory follow-up service, right? So we build dampers and UL comes into our damper manufacturers' locations and verifies the products we build and ship are the ones we tested and certified, right? We need to ensure the quality in production to ensure the safety of buildings and occupants, right? It's a very important product. Not anybody can just test a damper and start selling fire dampers. You have to meet these very specific requirements. So if you want to verify the UL listing, you go to ul.com, register for their product IQ, and you can go in and any product that has a UL rating can be found online. And for those of you who were born around the same time, those things to the left, those are called books, but today we just go to www.ul.com. All right, so what are my types of dampers? They're up there. We have fire dampers. We have smoke dampers. We have combination fire smoke dampers, and we also have ceiling radiation dampers. You notice I skipped corridor dampers. They are just a subset of combination fire smoke dampers. They undergo some additional testing. They get a 1-hour corridor rating for use in egress corridors. California Building Code requires that. It's in the International Building Code. It's not part of the National Building Code of Canada, so corridors are treated a little differently. But they are specifically tested for installation in a rated ceiling. Now that is not typical for fire dampers and fire smoke dampers. They go in concrete floors usually. But corridor dampers are specifically tested for the framing of corridor ceilings. We'll get into that a little more. Here's your definition of a fire damper. I won't read it to you. It's from NFPA 80. We only care about one thing. We restrict the passage of flame. If this is a fire-rated wall, it is a continuous barrier. I need to get air to the other side of that wall. What do? I put a hole in it. That barrier is no longer continuous. That damper makes up the hole in the event of a fire. Some common pictures of dampers. Your extreme left, that's what we call a curtain fire damper, most commonly used and specified. The center is a true round for your round duct penetration, spiral duct, things of that nature. And then we have a multi-blade fire damper. It looks very much like a control damper. It's built very similarly, but it does feature a fusible link and a spring and is a UL rated product. So as I mentioned earlier, that is the reason why we put fire dampers. You have an unprotected partition, flame will pass through it. When you protect it, it stops the spread of that fire. We know we need them. Containment and compartmentation, they just told you about them. But unfortunately, what they say is necessity is the mother of invention, right? Not for life safety. Unfortunately, we need tragedy to see change. Great Chicago fire, we build buildings differently. Triangle Shirtwaist Factory fire, we inspect buildings differently. We make sure our fire exits aren't blocked. MGM Grand Hotel fire of 1980. 85 people died, 700 injured, $223 million in 1980 worth of legal settlements. Essentially, there was a fire in an unoccupied occupancy called the Deli. A motor sparked. I was born in the 80s. I remember most of it. If you remember the hair and the clothes, think of the building materials. All toxic smoke was created when that burned and melted. And unfortunately, that smoke spread through the HVAC system. The dampers in the main unit over the casino were found in a manner in which they couldn't close. They were bolted open. There was no code requiring the periodic inspection or the occupancy inspection of a fire damper or a smoke damper. We put them in, we set it and forget it, and unfortunately, this led to the smoke spreading through the towers. 75 of those 85 people who died from smoke inhalation and carbon monoxide poisoning. It is the major killer in fires. I'm not saying all 85 people would have been spared, but if one person's life was saved because of those dampers, that is why we need dampers today. So this sparked the modern day code movement. All right, so it started in Clark County in Las Vegas, and then it propagated east, and then eventually when we changed all the building codes, we adopted the latest and greatest, and we'll get into the codes in a little bit. Fire dampers work pretty simply. It's a fusible link. It's a mechanical closure. There's no electric actuator. There's no pneumatic actuator. It is a bimetallic disc. It's got a solder that holds it together. That solder melts at the specified temperature. Building code says minimum 50 degrees above ambient, minimum, and I think it's 160 degrees minimum, right? So on a curtain fire damper, it's very simple. There's a fusible link. There's a blade pack. That's an accordion-style blade pack. When that fusible link melts, it just drops. Think of at home when you pull your curtains, you pull that little drawstring, the blades drop. Very similar action. This has a helical spring attached to the jack shaft on the right-hand side. When that fusible link melts, that spring uncoils, spinning that jack shaft. If those blades were open, they would slam closed. Right? So it's automatic, instantaneous closure once we reach the set point of that fusible link. 165 is common. We do see 212. We do see 286. So fire dampers and combination fire smoke dampers, most installations require a sleeve. The only installation that we commonly inquire that doesn't require a sleeve would be in a transfer wall, where you can direct attach the fire damper directly to the barrier using the retaining angle method without interfering with the operation of a damper. A sleeve would not be required. But if a sleeve is required, these are the common types. Upper left-hand corner, God bless you. Type A, we're just putting a sleeve on that damper. Let's pretend that these dampers are 12 by 12, 12 in the width, 12 inches in the height. That A-type damper has the blade pack in your airstream that's creating pressure drop, turbulence, noise. Not the most efficient damper for your system, but usually the least cost. If we need a step up from that, a little better performance, maybe a little more cost, we go to our Type B fire damper. That's the most commonly specified. It's the combination of the best performance for the lowest cost. What it does is it grows the height of the damper 2, maybe 3 inches, depending on the size. It puts a transition, we call that a hi-hat. Think of a top hat, Mr. Peanut. And it takes that blade pack out of the airstream. So you still have a 12 by 12 duct opening to attach your duct to, but your wall opening is now going to grow in order to accommodate that transition, that blank off, that hi-hat. So maybe it's 12 by 14. So the unit cost of that damper went up a little bit, but we call these about 96 to 98% free area. They do pretty well in pressure drop. The last three here are your type C's transitions, right? We have square to round, square to oval, square to square. These would be considered your 100% or your maximum free area dampers, lowest pressure drop. But again, that damper has to grow in size. Your opening has to grow in size to accommodate those transitions. When we go through our 555 series of tests, we go through a litany of tests to earn our certification, right? We replicate as much real-world conditions as we can in a laboratory, and we do that uniformly across the industry for every damper that's certified. So my specifiers can look at manufacturer A and manufacturer B and be assured they were all tested to the same requirements. There's no difference, there's no interpretation, and it's all unanimous, homogeneous. When we go through that testing, we earn our certification, whatever's on that UL label. So I call this my damper Carfax. When I speak to my installing contractors and they call me and they say, Michael, I need a fire damper. That's the equivalent of you calling your car salesman saying, I need a car. They can't sell you a car without asking you at least 10 more questions. Here's a couple. We need to know what kind of a system I'm installing that damper in. Is it static or is it dynamic? And I will go over these bullet points in greater depth in a minute here. I need to understand what the hourly rating of my barrier is, right, to determine what the rating of my damper needs to be. Where am I putting this damper? Am I putting it on a wall or am I putting it on a floor? And one we don't often consider is access and service and testing. Can I get to the damper to do these things? Sometimes we need what's called an out-of-wall damper, and I'll go into that in more detail. So when we talk about the system, is it static or dynamic? The building code states fire dampers and ceiling radiation dampers that are listed for use in static systems shall only be installed in HVAC systems that are automatically shut down in the event of a fire. So my fire damper does not have to overcome velocity and pressure or airflow moving through the ductwork. It's what we call still air. So maybe a smoke detector, a fire alarm panel, something in your design says, turn my units off. My dampers do not have to overcome those forces. That is considered static. The specification for that fire damper will not include a pressure or velocity rating because it has not been tested for either. The opposite would be a dynamic system. My fans are running. That's either intentionally or unintentionally. Intentionally, engineered smoke control system. I'm using a series of fans, dampers, doors, and other equipment to control, isolate, and move and evacuate smoke. Unintentionally, residential multifamily. I have a unitary heating product in a closet. I've got a ceiling radiation damper. What's telling that residential heating and cooling product to turn off? Nothing. That ceiling radiation damper is now in a dynamic condition. If you want to know more about that, show up at 3 o'clock. We're not going to go into that today. 3 o'clock will be an in-depth look on ceiling radiation dampers. That was such a shameless plug, I apologize. All right. So how do we know what the hourly rating requirement is? We simply go to the building code and we know the dampers are tested for 1.5 hours and 3-hour use for fire dampers and combination fire smoke. And the building code simply says, if the penetration is less than 3 hours, use a 1.5 hour damper. If it's 3 hours or greater, use a 3-hour damper. So a 2-hour assembly will get a 1.5 hour damper, and a 4-hour assembly will get a 3-hour damper. There are no such thing as 2-hour and 4-hour rated fire and combination fire smoke dampers in the U.S. I'll go into the out-of-wall in a little bit here. I got that in a couple other slides there. So we're going to jump into smoke dampers. There's so much material here to cover with life safety dampers. I've done this presentation at least 1,000 times for the last 10 years. And I will talk for 3 hours straight, still not scratch the surface on dampers. So we're going to do as much high level as we can, and I encourage questions or anybody to come talk to me afterwards. But what is a smoke damper? There it is. Pretty simple. We are controlling the movement of smoke. Now we use the word movement, so we know the air is always moving. Smoke dampers are always considered dynamic. They have an actuator. They will have a velocity and a pressure rating. And we know that smoke is the major killer, right? Fire destroys. We want to stop the spread of that destructive fire, but the people will die from smoke. Sprinklers are great. They put out fires. They do nothing to mitigate the effects of smoke. All right, so we look at the codes. We look at some of the changes in the last 10 to 15 years. We always have to remember, life safety dampers are part of a layered life safety strategy. They're not dampers alone, don't do the job. dampers, sprinklers, doors, everything is part of the life safety system. Right? I just listened to a gentleman talking about high-performance HVAC systems. The building is part of that. The actual structure is part of that. Your building, your barriers, your doors, everything is part of the life safety system. So just like we had a Carfax on fire dampers, we have them on smoke dampers. They go through that 555S standard. And we need to know, what is the leakage class? So leakage is the amount of air that will pass through the damper when the blades are in the closed position, and that air will carry smoke. So that is, of course, one of the most important things we need to know. We told you that smoke dampers are a dynamic condition. Velocity and pressure ratings, we need to know what those are as well. The operational temperature. So this kind of misleads folks. Smoke dampers are not tested under fire conditions. They control the movement of smoke. That operational temperature refers to the actuator. Or the actuator will have a 250 or 350 rating. And essentially, if you read the actuator literature, that gives you a period of use during that elevated temperature condition to pretty much allow the damper to do what it has to do. Close or open one more time. And then the fail position. So now when we talk about smoke dampers and specifically engineered smoke control systems, when a fire smoke damper or a smoke damper loses power, that actuator becomes useless. They usually contain a spring inside of them. That spring has enough torque to do something to that damper one more time. Fully close it or fully open it. Most combination fire smoke dampers, when they lose power, they're going to want to close to stop the spread of that fire. But smoke dampers, if that ductwork is part of your smoke control system, and your building loses power, and that damper fails in the closed position, that ductwork is effectively you can no longer use it. So you may need that damper to fail in the open position so you can continue to evacuate smoke and do what you need to do. This information should be detailed on your smoke control drawings, your control plan, or on your mechanical plans. It is very important. Dampers that are rated and shipped as fail closed, you cannot just simply flip the actuator over and call it fail open. That is a tested and certified rating. It has to be reflected on the label of the damper shipped from the factory. So now you're going to have a damper that says it's fail closed and is actually failing open, and your building inspector should not allow that. So you must get that right at time of order. So let's talk about leakage a little bit. These are the leakage class definitions from UL 555S. I've got an asterisk there above Class 3. International Building Code requires a minimum of Class 2 leakage rated dampers. We have Class 3 still in the standard for export. We send them to other countries that don't follow the International Building Code, and there are some applications that might use a Class 3 damper. But you can see what the leakage ratings are, 80 CFM per square foot at Class 3. And then we jump to a Class 2, it's 4 times tighter. It seals that much better. It's 20 CFM leakage per square foot. And then our Class 1, 8 CFM. That's tight, low leakage damper. Now don't get this confused with AMCA leakage certifications like Class 1A, Class 1. Those are for control dampers and other volume control applications, not life safety dampers. What does this all mean? So everything I'm going to show you now is hypothetical. Well, you're all smart people, take physics, throw it out the window. You're going to see some times. Those are not real times, they're theoretical, so you understand the scope of what the difference in leakage actually does for the occupant. So let's say this room is 20 feet by 20 feet with an 8-foot ceiling. I've got a 24 by 24 smoke damper, ducted. Let's pretend it's closed. Let's pretend there's smoke circulating through that ductwork. If that damper was Class 3 rated, that room would fill up with smoke in 10 minutes. That is not a very effective damper. That's why we don't use them in the U.S. International Building Code, again, requires minimum Class 2. If it was a Class 2 damper, hypothetically, that room would fill up with smoke in 40 minutes. Commercial building, couple floors, mid-rise, that's enough for healthy, capable people to stand up and walk out and evacuate in a safe and orderly manner. Class 1, 100 minutes, theoretically, that room would fill up with smoke. Surgical suites, isolation rooms, high-rise buildings, places where people can't move quickly or easily or preventably cannot move. Hospitals, healthcare, things of that nature. So there's no real code saying you must use a Class 1, but there's a lot of design guidance and owner preference in Class 1. You might see it institutional, educational, governmental, things of that nature. So we did talk about that operational temperature rating again for the smoke damper. So again, that's that max rating that the temperature can operate. At least one more time. Whenever we talk about fire smoke dampers, the over specification of dampers does not increase the safety of your building or the performance of your system. It costs your owner money, period. The only time we really should be seeing 350 rated dampers is if I have other high temperature rated equipment in a smoke control system. My fans are high temperature, other high temperature rated equipment, we want our dampers to have the same rating. But if I don't have anything rated for high temperature, and we do what I call the garbage can spec, and we just say, well, 350 is better than 250, all you did was just create a more expensive damper. In order to get to 350, the torque rating of the actuator has to go up, which means your cost is going to go up. That happens with velocity, that happens with pressure. Standard commercial HVAC ductwork, 2 inches, 1,500 feet per minute. Basic airflow rating for a fire damper, 4,000 or 2,000 feet per minute at 4 inches. If you specified 4,000 feet per minute at 8 inches, in a duct system that's rated for 2 inches, 1,500 feet, you paid a lot of money for a damper that doesn't do anything extra. That torque rating of that actuator, in a standard condition, would be maybe a 30-inch pound actuator. Now to go to 4,000 feet at 8 inches, I jump to a 180-inch pound actuator. If anybody knows anything about actuators, that's a pretty big jump in cost. And we usually see more than one damper on a job, right? So multiply that by 5, 10, 500. Now you've just cost your owner that much money, and your building is no more safer. So again, passive smoke control is the way we use smoke dampers, just to close, prevent the spread of smoke. Pretty simple. We call that Chapter 7 of the International Building Code. So if we're looking at the IBC, we see Chapter 7, fire and smoke protection features, and Chapter 9 as well. Engineered smoke control systems will fall in Chapter 9, but Chapter 7 is going to be your passive dampers, and again, that's that compartmentalization, the containment part of the dampers. Then we have your engineered smoke control system. This is a rudimentary diagram of what one would look like for fancy videos. So I got my supply hood on the left, got my return fan on the right, I've got 3 floors, I've got some series of dampers. Well, fire broke out. So now my building is going to say, okay, we're going to need to start closing dampers and leaving dampers open so we can create pressurized zones on the 1st and 3rd floor. So now we've isolated and trapped that smoke, and we have our return dampers open on the 2nd floor. We're able to evacuate that. That would be a non-dedicated HVAC smoke control system. Pretty typical. So again, that would be your Chapter 9 NFPA 92 use of your smoke dampers. Combination fire smoke dampers. It's pretty simple. Everything I just talked about, from fire dampers to smoke dampers, in one device. In the past, if you had a penetration requirement that needed fire protection and smoke protection, you needed 2 dampers. Now you need 1. So we lowered your pressure drop, lowered your install cost, lowered your equipment cost. We have a device that does those jobs. So everything we just talked about now applies to fire smoke damper. When we talked about the mounting position earlier, I didn't really get into the walls and floors. So everything that is on the rating of the damper is labeled by the manufacturer when the damper ships. We have a requirement of what we need to put on that damper. Our inspectors are going to verify that what's on their documentation matches what's on that label. So if you order a damper that needs to be installed in a wall, so it's a vertically orientated damper, but it actually needs to go into a floor. Well, I told you earlier that curtain fire dampers work on the principle of gravity when they're static. Gravity pulls that curtain down. If I take that same damper and put it in a floor, is it going to work? No. It needs a spring to assist in that closure. And that damper will have a label that says V or vertical, and then you go to put it in a floor and the building inspector says, no, that's no good. I can't ship you a spring. You can't modify that damper in the field. You just have to buy a new one. It's very important that we understand how we're installing these products, right? So again, I'll borrow from a previous presenter. You can have the best system in the world on paper. You can model it. It's very installation sensitive, these fire smoke dampers, right? We have to make sure we're installing them properly so they will do their intended job. And so we'll talk about that now for the access for the out-of-wall dampers. So most in-wall oh no, I got ahead of myself. Let me switch gears to how fire smoke dampers work, because this is important. So we talked about the fusible link closure of a fire damper. Well, fire smoke dampers respond to a heat sensing device, a smoke detector, or maybe a control signal. In your the center there, that's what we call a resettable, reusable link, right? So all of your specifications for fire dampers have this resettable link, right? All it is an electronic link. It's got a heat sensing device, that little circle. It's a thermal disc. As the air passes across it, it will literally pop, and it is wired in series with the actuator. It will break that series, the actuator will lose power, and the damper will close. Could have a smoke detector, it could sense smoke, it's wired in series with the actuator, it'll cut power and do the same thing. Right? So we have couple different types of heat sensing devices. There's single temperature devices. Could be 165, 212, 250, 350. There's dual temperature devices. For a fire smoke damper that's intended for use in an engineered smoke control system, this gives you reopenable control. You'll set a low limit, 165 on the fire smoke damper. You'll set a high limit, 350. Building will report a fire, the dampers will close. I have the ability to reopen that damper from my fire alarm control panel, building management system, somewhere. I can push a button, reopen that damper so I can use it for smoke control. Once that fire gets more intense and that high limit is reached, the damper automatically closes again and becomes part of that wall, makes up that containment, that compartmentalization of the barrier. The last device up there, that is a combination of a heat sensing device and what we call a position indicating device. So for the maintenance and testing of dampers, we can give them the capability to report their position, fully open or fully closed, back to another signaling device, maybe a fan, a fire alarm control panel, building management system, something like that. We can interlock it with another piece of equipment, and that blade device tells us the true position of the damper. We have different accessories. Again, we talked about the code. We'll talk about the code required testing. We have accessories as damper manufacturers that are very common that make that testing easier for our facilities managers or building owners. That testing can be accomplished through other means, through the electrical wiring, just through the heat testing of the dampers themselves, but it saves time and it saves money. So for hospitals, educational, institutional, places with very large maintenance budgets, lots of dampers, these options give the testing folks a lot of savings. So the momentary test switch is exactly that, momentary. It's a push button. I climb up on a ladder, I push a button. As my finger is holding that button down, I'm breaking that circuit. I'm losing power to my actuator. That damper is physically closing. That's what we would call a visual inspection tool. I'm physically at the damper. I'm physically looking at it open and closing. Then I can wire in a remote test switch. I can put it here. I can have a damper way up there, and all I got to do is walk up to it, push a button, and then just wait for those lights to change color. Green open, red closed. That satisfies the remote testing requirements of NFPA for your life cycle testing of the dampers. Already spoke about corridor dampers, so I won't reread that, but again, it's just a special type of fire smoke damper, and I bring them up more and more. Building codes are what? Absolute minimums. They are the least you can do to make your building safe. There's nothing saying you couldn't add dampers to provide a safer building, and what we see is a lot of the designers from the West Coast, from events that happened in this country in the last couple of years, have decided to leave California, take their best practices with them. That includes inspectors, that includes installers. So we're starting to see corridor dampers pop up in drawings all across the country now. There's nothing wrong with that. They just need to be applied correctly. There's a specific installation for them. So if anybody's outside of California interested in corridor dampers, take a look at your installation instructions for fire smoke dampers. They're not the same as your regular fire smoke damper. Just quick note on actuators, they must be factory installed. So your actuator and your damper is an assembly. The damper by itself is not rated. The fire smoke damper and the actuator are a combination tested and certified by UL. They give us a plan, like we call it our procedure. I've got a whole set of tables that says the size of my damper, the ratings required, and what actuator I've tested and have approved. So for my specifiers in the audience, don't go into your written specs and say every actuator to be actuator model XYZ. Damper manufacturer A tests with actuator A. Damper manufacturer B tests with actuator B, C, so on and so forth. We all choose, based on our own R&D and our own products, what we want to test and rate. No two listings are identical for any damper manufacturer. We have shared and common listings, but each model is tested and certified independently. So for my specifiers, my installers, if you're used to manufacturer A and that's all you know, and you have to use another manufacturer, do your research. Don't assume everything is the same. Ceiling radiation dampers, we're going to just touch on it for a second because we're going to talk about that for an hour at 3 o'clock. They limit radiant heat transfer. That's their only job. Not fire, not smoke, heat. They're very concerned with the transfer of heat. They protect the structural integrity of the structure above it. So think of your high-rise and low-rise multifamily, dorms, smaller hotels, motels, things of that nature. I've got a fire-rated ceiling assembly. That diffuser, that air outlet, that place in that T-bar, that is a break in the continuity of that ceiling membrane. So the radiation damper, in conjunction with possibly a thermal blanket, makes up that continuity, protects the structure above it. Steel truss from cracking, warping, concrete from exploding, wood truss from combusting. Obviously, firefighters can fall through roofs and floors. It's a major killer in the firefighter community. You know, if you think about single-family homes and how many firefighters fall through those roofs, those are wood trusses. They're not protected. There's no code requirement for a ceiling radiation damper. And I'm not saying there should be either, so don't misconstrue that. We'll touch on codes and standards. I will just say I am not a degreed engineer. I've been doing this for some time. I tell all of my engineers, you guys know the building code better than I do. I will point you in the right direction, but the interpretation of the code is at the discretion of the building, the authority having jurisdiction, not me. All right, so it's our job to work together as a team to get to the right product, but I always encourage you guys to do your own research on the codes and standards. So we talk about the ICC, International Code Council. For those of you who don't know, back in 2000, we took all the regional codes, put them together, and took the least amount of required safety and made that our national standard. Right? Again, building codes are the minimum requirements to build a building. There's no high performance benefits. There's no extra safety in them. We go to Chapter 7 again for fire and smoke protection features. Everything you need to know is in Chapter 7. But the baseline requirements, the thing we always fall back on as damper manufacturers, they must be installed in accordance with the manufacturer's installation instructions. The number one question I get, Michael, can you approve this installation? I'm not a building inspector. I don't build walls. I build dampers. Not me personally, but I work for a company that builds dampers. So I don't approve anything. I give recommendations. I provide guidance. I can show you where things are in the code. But if you have something that is a little outside the scope of the manufacturer's installation details, I tell my contractors, call before you install. For my designers, call before you design. Talk to your damper manufacturers. Maybe there's a special product, or maybe there's a standard product. We want to make sure that we're building buildings safe in accordance with the code, but more importantly, we're installing them properly. So again, there's only a handful of installing contractors here. We don't like to point fingers at all. But a lot of the deficiencies we find with dampers is not in the construction, it's not in the materials, it's in the installation. Something was missed, something was assumed, or something wasn't done properly. So a lot of different things in the building code. I'm not going to go through all of them. Again, Chapter 7 has all the information you're going to need, where dampers are required. This presentation will have a little cheat sheet here. It's not an end-all, be-all, but it'll tell you the wall type, the code section that it's referenced from, and the type of protection that's required. So one thing that's important, ceiling damper test standards. Ceiling dampers and fire dampers are not the same thing. They both have fusible links. They're both tested by UL, but they do not do the same thing. As I told you, fire dampers prevent the spread of flame. Ceiling radiation dampers prevent the spread of radiant heat. So if I have a requirement where a ceiling damper is required by code, I cannot substitute a horizontal curtain fire damper. Now somebody in here just shook their head because they said, I just did that yesterday. It happens every day all over the country. There is not a single fire damper approved for installation in a wood-framed ceiling. Period, end of story. Don't ever do it again. I don't care if your engineers put it on your drawing. It's not approved. It should not be done. The simple answer is There's no way to install that damper properly. Nobody's ever tested it. If I can't install it properly, it's not going to protect lives. Now we understand you have a code requirement to meet. So again, call your designers, help work with that. They're a completely different damper. Then get even more confusing, something we'll dip into at 3 o'clock a little more. There's two different types of ceiling radiation dampers. There's those intended for use where hinge door dampers are allowed. That's your fire-rated T-bar ceilings with the steel truss rated up to 3 hours, most common application. Then you have very specific floor ceiling assemblies that have a specific manufacturer's damper tested. That's our wood truss and wood joist, multifamily. Those assemblies are very specific as to what damper is approved. Their substitutions are not allowed in those tested assemblies. Again, if that just piqued your interest, come back at 3 o'clock. So we already told you fire dampers are not ceiling dampers, and we're going to touch on periodic testing requirements. So the International Fire Code references in section 7. Basically, read NFPA 80 and 105 for your testing requirements. And in them, testing at 80 and 105, basically after you install a damper, contractors to make sure it works, right? That's how our operational test is conducted. Then 1 year after that, the damper is tested again. And then 4 years after that, I test my damper again, and then every 4 years, I test that damper, unless I'm a hospital, and it's every 6 years. You might think to yourself, that's kind of excessive. I just tested it 1 year, why am I testing it a year later? Think about what happens in a building. Developer comes in, builds a building. He has no idea who his tenant is. Tenant moves in. Hey, I got to put up some walls. I need more people. I got to move some things. Anybody here in IT? Okay, good. Oh, man. IT guys love fire damper holes. They love to run their cables right through them. They don't know what a fire damper... This guy will tomorrow, so he'll be the best IT guy in the world. But most of them don't. They run their cables through it, right? And we see it all the time. So we got to make sure that we are constantly checking to make sure that the conditions didn't change. And then every 4 years, we're assured as long as your system is maintained, operating properly, doing everything you're supposed to be doing, dampers are maintenance free. Right? We might need to clean them if it's excessively dirty air and an outside air intake, things of that nature, but we don't need to lubricate them. We don't need to change the actuators every period of time, right? So we want to come in every 4 years, and you see some of these pictures. These aren't staged. These are real pictures from inspections, right? We see blocks of woods. We see Coke cans. We see, empty caulk containers, all of that nature, right? So again, and that would have prevented possibly the loss of life at the MGM Grand, right? Come through, you do your inspection. Hey, those dampers are bolted open. That would have been an easy fix, right? It's very important. Talk about certified ratings program, the AMCA 511. I'm sure you're all familiar with AMCA. They're the host of this. They do a air performance certification, or pressure drop, right? So we're all hearing all these great things about high performance, energy efficiency, fan input power, FEI, all these great things. Dampers create pressure drop. It's a consequence of being in the airstream, right? So AMCA has a certification program. I call it the serial nutritional facts. I can take all my damper manufacturers, put them side by side. We test the same 5 sizes for all manufacturers, and you're required to pick a test figure and publish at least one of them. You can optionally publish 2, you can optionally publish 3. There's no limit. This is the most common one on the bottom. That's 5.3. It's a fully ducted inlet and a fully ducted outlet, straight duct run. For my designers, how many times do you actually put that on your drawings? But when you're estimating the pressure loss of your damper, this is the number you're using, right? So understand there's different figures. Not every manufacturer has this data available, but if you want to really design a high-performance system to ensure your fans, motors, and everything are sized appropriately and within fan input power levels and FEI and all that good stuff, think about the installation. It matters. Am I a grill-mounted damper? Am I a plenum-mounted damper? Do I have an elbow? Do I have a turning vane? Do I have all this other stuff in the ductwork that I don't know about that's going to create additional pressure drop? So be cognizant of that. This is a pretty typical pressure drop specification in the industry. We pick a single certified rating point, and we write dampers at this rating point should not exceed this pressure drop. This is a certified rating for a 12 by 12. That is not a certified rating for a 12 by 13 or an 11 by 13. Only these 5 sizes are certified. This type of pressure drop specification does not guarantee anything other than that one damper's performance will meet that requirement. So if you have a sensitive application or you want to make sure you're designing efficiently, think about what pressure drop values you're using to estimate your system, and then maybe think about scheduling dampers. How many of you design engineers actually schedule your dampers? Wow, you all just broke my heart. Did you hear that? That was the sound of my heart breaking. Dampers should be scheduled. I know it sounds, why? Putting a little line on a drawing and expecting everybody to understand what that damper is, what the service clearance is, what the conflicts are, there's doing nobody any favors. You know why dampers create such a problem? Because we don't think about them enough in our design, in our planning. They're an afterthought. Oops, that was a rated wall. Somebody write an RFI and slap a damper in it. I wish we had a little more forethought, a little more planning. So we'll go through, we'll keep going here. So here's why it matters. My 5.3 ducted in and out. It's just a sample damper. Let's call it a 12 by 12. I accidentally cut off the bottom. 12 by 12 damper is going to run at about 0.08 inches at 1,500 feet per minute velocity. Take that same damper and put it in figure 5.5 in a blunt amount. The pressure drop went from 0.08 to 0.48. Now that's obviously for one specific damper, one specific model. This is a V-blade fire smoke damper, the most common damper specified. Now let's say I had other things in that ductwork, right? You got to think about this when you're designing your system. So I don't know, you guys are going through if you're using Revit. Anybody here use Revit? Model your dampers? Okay, so do you use Revit models? Do you use anything that... We'll talk after. But you want to be using as much information to design up front. You don't want to have to come back and redesign your system 3 times because your pressure drop of your dampers isn't what you thought it was. All right, so lastly, we'll just touch on installation. Again, I don't approve anything. I can't approve your installation. I can tell you what you need, and this is the easiest way. You need a rated barrier, you need the correct barrier, you need it built properly. I need it approved. All right, so if you start having questions on the studs, the way the barrier is constructed, and we start coming to Michael, hey Michael, my contractor didn't have 10-foot studs, so he spliced an 8-foot and a 2-foot. Is that okay? I don't make that call. The building inspector does. All right? Or my building inspector, my contractor says, hey, I got to run my ductwork at an angle. I need to install the damper this way. We'll read the instructions. Dampers must be plumbed square and straight. So make sure the barriers are good, then you're good. You don't have to select the right listed product. We all know how to do that. We know what the rating of our barrier is. We know what the test standards are. We know where to find it in the code. We select the right product. And then, of course, like I said, it has to be installed properly. Take a curtain fire damper and install it upside down. You've met the code, you got a damper installed, but it's not installed properly, right? So here's our square opening. So again, we don't have a lot, we have a couple installing contractors. Call before you install. You don't have an opening that's built properly, don't stick a damper in it and go, hey, that barrier wasn't built right. Now you're gonna have to take that damper out. You could possibly damage it. You might need to reorder it, all right? So call before you install. Framing requirements are outlined in our manual. It is not the intent of the damper manufacturer to tell you how to build your barrier. It's our intent to tell you how to support and install the damper. So if you put a damper right here and we frame it perfectly and everything's good, and then right next to it you have a 5-foot hole. Is that damper installed properly? Sure, but that barrier's got a giant hole. That's not my problem. Let's put a dashed line around my damper. I can't tell you how to build the barrier. So remember that. One thing we always like to point out in wood stud construction, wood stud walls, those openings need to be lined in sheetrock. Remember that. Steel stud, no. Wood studs, yes. That often gets overlooked, and that's a costly mistake. So we showed you those pictures of the different types of fire dampers, fire smoke dampers. Talked about square dampers. Now there's a true round damper. This is not a new technology. They've been around for quite a long time. Not every manufacturer actually has a true round damper, but there are advantages. But the first thing to say, from the perspective of the code, a true round damper is the same as a square damper. It's got the same rating, same testing. There's nothing different. For the installation, that is the framing of a damper that is square. That is also the framing of a damper that is round. They come with a retaining plate. Fire smoke dampers and fire dampers require retaining angles in their installation. That's a structural component that keeps the damper from falling out of the wall in the event of debris falling out of the ceiling. We don't put a retaining angle on round dampers. We put a retaining plate. That square plate goes over the square hole. I've got the required clearance around that opening with that plate. I install that damper. The only caveat to true round dampers is based on the design of this plate. See this clamping screw and assembly? Well, that cannot go under the sheetrock. It has to go over the sheetrock. So there could be an aesthetic component to it for the architect. Could be a coordination between the trades. A lot of guys like to go in and hang dampers before the sheetrock's up. You can do that with a square damper. Cannot do that with a round damper. But there are benefits, cost benefits. They're usually cheaper in cost, and huge performance benefits. Think of a square damper with a round transition. That's multi-blade versus a single blade damper. So they're lower in pressure drop, lower in cost, and they are actually easier to install than a square damper. Here's your typical installation of that fire damper, that square curtain fire damper. So our number 3 is that retaining angle I just mentioned. So we do a test at UL. It's called the duck drop test. Drop a 500-pound bucket of sand on this breakaway joint, that number 4, that little S clip. Right? That is a slip and drive joint that allows the damper and its sleeve to stay in the wall, and then your mating ductwork to break away in the event of things falling out of the fire. And that retaining angle could be on one side of the damper, on both sides, and again, it's retaining the damper from falling out of the wall. If you don't pass that test in UL, you don't get your certification for your damper. Other things to point out, and this is both for fire dampers and for fire smoke dampers. Number 5, your expansion clearance. Installing contractors, that's a gap around the damper that allows the metal, when it heats up, to expand and for the damper to operate properly. The dampers will not work without it if it is required. Double-sided angle dampers, 2-sided angle dampers require that expansion clearance. In-wall rated dampers require that expansion clearance. Every once in a while, you'll get an owner or a building inspector that says, hey, that's a big hole around the damper. We see that when we put single-sided angles on. One side looks finished. It has a retaining angle, looks clean. The back side has no angle and has a gap around the damper. So it just, intuitively, you think that's not right. It is. But a lot of times we get building inspectors and owners that say, put some material, put some fire stop material, put some putty, that is a no-no. Do not fill the gap. There is a specific installation for fire stop caulking. You have to follow those instructions if you want to caulk using a retaining clip installation, not a retaining angle installation. Here's your typical single-sided angle. So shaft walls, 1.5 hour rated dampers up to a certain size listed up there can be used with the single-sided angle. We put the fastener in the barrier, put the fastener in the sleeve. That keeps that damper in the wall. And it's good for, again, dampers that don't have that access on the opposite side. But then you have your 2-sided angle. The fastener for a 2-sided angle only goes in the damper sleeve. The theory of floating in that expansion clearance when I'm expanding under heat is the same for the retaining angle. If I fasten the angle to the wall, I now have a rigid installation. That damper will not be able to move. It's not approved for have the fastener on the wall on a 2-sided angle. So again, the fastener only goes through the damper sleeve. These are very easy things to miss in inspection. There's a checklist of things I've created. There's a spacing requirement of that fastener. It usually reads, first fastener starts 2 inches from the end, minimum of 2 fasteners, and a fastener every X number of inches. Well, when you buy an angle from a damper manufacturer, we have the ability to pre-punch those holes, make it nice and neat for the installing contractor. No thought. Angles could be made in the field, then the contractor has to then measure and put those fasteners where they need to go. I don't know of any building inspectors that carry rulers with them, but a lot of them will actually look at that. So that's something to keep an eye on for my installers. Alternatively, that angle has to wrap around the damper on all 4 sides standard. You can get a UL approval for a 3-sided angle. Very special installations, but again, it must be a UL approved solution. If you are an installing contractor and you're tight to the ceiling, tight to the slab, tight to the wall, we're going to zip a screw right through the damper sleeve into that substrate and then put the 3-sided angle on. Some manufacturers have all 3 of these installations. Some have 2, some have none. If you have this condition in the field, call your damper representative and ask them for this instruction. Smoke dampers, the only difference between a fire smoke damper and a smoke damper or a fire damper is that the damper is not tested under fire conditions like we learned earlier, so it does not have to be in the barrier itself. It could be up to 2 feet outside of the barrier, up to 24 inches. The only exception is I cannot have a duct drop, an air inlet or outlet, between the damper and the barrier, or between the barrier and the damper. Access doors required by code. NFPA 105 will require a minimum of 12-inch square or a removable duct section. So our 6x6 dampers require an access door of 12 inches square or a removable duct section. Remember that. And of course, we should be labeling dampers outside the access panel. I play this game. I go to the hospital a lot, unfortunately, and I play this game all the time. Find the damper. You got a couple hours to kill, just walk around the ceiling and looking for those signs. You don't see them in many other occupancies but hospitals, but they are there. All right, a couple resources for more information. Again, AMCA, Air Movement Control Association, Publication 503. I am the chair of that committee, is being updated. Got a couple of my colleagues who are on that committee in the room with me as well. There's a lot of good information in there. This will be an application available for purchase through AMCA. It'll also have the guide for commissioning and testing of fire smoke dampers included within it. That'll be done here in the next couple of months. That'll be a really great resource for you guys to check out. That guide is what I just mentioned. We're going to add that to that publication 503, as well as possibly post it on the AMCA website as a standalone publication. This is great for my installers, anybody new to the industry. Same thing here. This will have all the information that AMCA could put on paper about fire, smoke, and ceiling radiation dampers. All right, so there's going to be a lot of good stuff in there. And then lastly is Underwriters Laboratory Marketing Application Guide. This is the cover from 2014. They haven't updated the cover, but they have a 2024 version, I believe, or 2021 version from UL. Really good information, particularly their information about corridor dampers and ceiling radiation dampers, but a lot of good information there. Last book here, Fire Stopping Joint Systems and Dampers by Jay Woodward. So the International Code Council, the IFC, ICC approved this book. It actually went through AMCA. A lot of damper manufacturers went through and read through this. This is a great resource for all things dampers, as well as fire stopping and joint systems. So I think that is all I have today. It was a ton of information. And I'm supposing I've got at least 100 questions, but I'll start with just one. I know this group right here has got a question. You guys you've been eyeing me all day. What do you got for me?
How often do you see damper scheduled versus a kind of generic specification?
It's growing. If I had to put a number to it, 10% of the time. In your larger jobs, we see it more often. I see it more on the West Coast out of California than I do on the East Coast.
We have more than one style of damper, more needs. We have multiple types of dampers.
Multiple types of dampers, but again, we have to consider the performance of these, right? So a lot of people just think of dampers. It's a piece of metal, it doesn't do anything. It's actually a really highly engineered product. It's got a lot of neat features to it. From a control perspective, we can save a lot of money doing really good things, but we never think about the impact to the performance of the system. You're going to have dampers, you could have a duct run with 3, 4, 5 dampers, plus a balancing damper, plus a volume a control damper. Dampers create pressure drops. So I like to schedule them to ensure that your system is designed properly. Not all dampers are created equal. Different manufacturers build dampers differently, and that affects the performance of the damper. Some damper manufacturers have very efficient dampers through the manufacturing process. Some don't. When we treat them all the same, and we're in a bid situation, you're not guaranteed that what you put on that drawing is what you're going to get. So we're trying to encourage the industry to start looking at pressure drop from a maximum accepted value, or maybe an application perspective, because we all just look at that straight duct run value. How many of you guys here, designers, have a piece of paper on your desk that says dampers under this size use this pressure drop? Yeah, there you go. One of you were brave, thank you. Get this man a Pepsi. No. it's a lot of the ways we do things. I mean, that's how I was an estimator, for many years. That's how I had a little piece of paper. It said, up to this size, use this, right? Rules of thumb engineering is what we call it. Well, with all the requirements for fan energy, don't you want to ensure your products have the lowest pressure drop or the most efficient, not just fill a hole to meet code? I used to be in the GRD world. You know what we call GRDs? Hole covers, right? That's an insult to anybody that manufactures GRD. It's a highly engineered product. It takes a lot of, same thing with dampers. They're not just open and closed products that are a necessary evil. They're a life-saving product that can make your building efficient and safer.
If we want to specify pressure drop, you said you're only listing those 3 scenarios and only those, 4 or 5 sizes?
Correct.
So we can't say it's this dimension and we want a max pressure drop of 0.08 because they wouldn't even have that test data. If it's
Some manufacturers have more data available than others. So now when we talk about certified versus non-certified, correct. All data, all sizes outside of those 5 are not certified. But some manufacturers can provide that data. Some manufacturers don't have easier access to that data because they've never tested it. So if you have a library of data for all 3 figures, you can provide that. Some selection softwares provide you with an as-built list of pressure drops. Some don't, because the industry has never forced designers to think about it. Just say, put a damper in because code requires it.
Would you typically report which of those, like what the test condition is, which diagram?
Yeah, so if I was a designer and we do this with certain designers, I tell them, think about the 3 basic. Am I terminating on a grill? Am I fully ducted, or am I terminating on a plenum? If you have a weird 90, those conditions nobody has test data for them. But if you at least consider that at the very least, or at least can look at it and go, this is straight duct run pressure drop data. I know I don't have this, but this is the only data I'm going to use. Let me put a safety factor on it. But let's talk about that safety factor. Those safety factors are causing us to oversize fans, oversize louvers, cost our system energy, cost our building owners money. Right? You can look at the fan and the wattage consumption of the fan based on the efficiency of the damper. It tells a completely different story. So again, it's a lot to think about with a sheet metal product that just opens and closes. So, good questions. Yes, sir.
You said for duct access panels, minimum size 12 inches squared.
12 inches squared.
12 by 12.
12 by 12, correct.
What if the duct is smaller than 12 inches?
It allows you a removable duct section. So you can basically clamp off 2 sections of duct, remove them, service your damper, put the ductwork back in. Or you can transition to bigger ductwork, put your access door in there, and then transition down to the smaller damper. So a lot of folks, I don't know, anybody here ever used a removable duct section? Unless you're in the state of, unless you're in Ohio, I don't think you have. That's where they come from, but it's just one of those things. Code put it in there so we can do it. All right, excellent. Any more questions? Yes, sir.
Who typically provides the smoke detector for a smoke damper?
We have options as damper manufacturers to provide them as a factory mounted and wired option. We don't like to do that. Our smoke detectors are usually a single type. The biggest problem with the smoke detectors offered by damper manufacturers, they are non-addressable. You have a smoke control system, you have a building management system, they're non-addressable. So now we have to add addressable components to read them, or they create problems and conflicts. I like to let the controls guys deal with that. Keep it out of the damper spec all day long. Sure, it's more money. You're buying something else from me. I don't want it. Because 9 times out of 10, I get a call. How do I bypass your smoke detector? Is that code compliant? And I'm like, well, yes, it is. But you just wasted a bunch of money for nothing. Right? Created a leakage point in your sleeve by putting a tube through the hole, through the sleeve. Added cost to your building owner. So I always put the smoke detectors on somebody else. That's the preferential way to do it. Good question. Very good question. Anybody else? Sam, you have a question back? No? Okay. Thought I saw you. All right, that's all I have for you folks. Again, please join me at 3 o'clock. If you're in the multifamily space, low-rise, high-rise, mid-rise construction, please join us at 3 o'clock, ceiling radiation dampers. But thank you so much for learning about dampers today. I really appreciate it. All right.